Hello friends, now we'll start the new topics. That is to find out the inverse of a matrix. Inverse of a matrix by using rows or the column transformation or by using the adjoint method. Now see this here. Definition: if A is a square matrix of order M and if there exists another square matrix B, then B of the same order such that AB is equals to BA is equals to I, where I is the of order M, then B is called as the inverse of A and is denoted by A inverse. Therefore, now B is equals to A inverse and therefore A into A inverse is equals to I, or A inverse into A is equals to also I. Therefore, we can find out the inverse of a matrix. Actually, what is meant by the inverse? Suppose if you have the number 5 and what is its a multiplicative inverse? Its a multiplicative inverse is 1 by 5. 5 into 1 by 5, that is equals to 1. The same thing is here for the matrix A into A inverse is equals to I, where I is the identity matrix. The order of the identity matrix depends on the order of this matrix A. Now see this here, the inverse of a matrix if exists can be obtained by using two methods. The first is elementary row or column transformation. Now, suppose that by the row transformation, if A is of the order 2 by 2, A into A inverse is equals to I and the elements of A are A11. It means that first row, first column, A12, first row, second column, A21, second row, first column, and A22, second row, second column. To find out the inverse of a matrix, we write in this fashion. That is A into A inverse is equals to I. Here is A inverse and I had taken here as the order of this matrix is 2 by 2. Therefore, I had taken the identity of this order, that is a 2 by 2, which is 1 0 0 1. Identity is always written in this manner. Then how to find out? What are the steps for to find out the inverse of a matrix by the transformation? And suppose that if you want to find out the inverse of a matrix by using the row transformation, the steps you must follow like this. Reduce first A11 to 1. A11 च्या ठिकाणी आपल्याला किती आणायचं आहे? 1 आणायचं आहे. आणि जर असेल then it is not necessary. Reduce A21 then reduce A21 to 0 and the next step is reduce A22 as 1 and then reduce A12 to 0. If they are already present, then it is not necessary, but follow these steps. A11 च्या ठिकाणी जर 1 असेल तर नो प्रॉब्लेम. A11 1 करताना जर A21 0 होत असेल तर नो प्रॉब्लेम, पुढची स्टेप. आणि जर 0 नसेल तर देन फॉलो दिस स्टेप. नेक्स्ट इज A22 1 करणार, पण A22 ऑलरेडी 1 असेल, then don't follow this step. Then make the A12 as a 0. Then you will get the inverse. Now this is reduced to the identity. म्हणजे हा जो मॅट्रिक्स आहे ते आयडेंटिटी तयार होणार आहे. त्याच वेळेस सायमल्टेनियसली या आयडेंटिटी मॅट्रिक्स वरती देखील हेच ऑपरेशन आपण परफॉर्म करणार आहोत. बऱ्याच वेळा विद्यार्थी या बाजूचे ऑपरेशन करतो पण इकडचे विसरतो. त्यामुळे हे देखील सायमल्टेनियसली ऑपरेशन्स करायचे आहेत. I into A inverse is equals to C. Therefore, I into identity into A inverse is the A inverse and that's why A inverse is equals to C. Now to find out the inverse of the matrix of the order 3 by 3 by using the transformation, row transformation, A into A inverse is equals to I. Again the elements are A11, A12, A13, A21, A22, A23, A31, 32, 33 and here is identity of the order 1 0 0 0, 1, 0, 0, 0, 1. Whenever we are performing the transformation with the help of the rows, or find out the inverse by using the row transformation, always write in this manner: A into A inverse is equals to I. Now my first step is, that is, reduce A 1 1 to 1, then A 2 1 and the 3 1 to 0. These are the steps. Then reduce A22 as a 1, then A12 and A32, that is equals to 0. The fifth step is A33 is 1, and then A13 and A23, these are the 0. When we perform the operation on the left hand side, at the same time you perform the operation on the right hand side also, then you will get, here is identity A inverse and here is another matrix. Therefore identity into A inverse is equals to A inverse, and that is equals to C, and this is the inverse of C. By using the column transformation for the order 2 by 2, for column transformation we write A inverse into A, and for the row we write here A into A inverse. That is a, here is a inverse into A is equals to I. Here is a inverse A11, A12, A21, A22, 1, 0, 0, 1. Now here we perform the column operation, means what? Make the first A11 0, sorry, A11 as 1, then A12 0, then A22 as 1, and 21 is 0. Now A11 reduced to 1, the first. Then A12, there is, that is a 0. A22 is 1 and A21 to 0. And in this way, you will get another matrix on the right hand side, and that is the inverse of that A. Therefore, here is a inverse into I, and A inverse into identity is again the inverse. Therefore, A inverse is equals to C. For the order 3 by 3, A inverse into A is equals to I. A inverse A11, A12, A13, A21, A22, A23, 31, 32, 33, 1, 0, 0, 0, 1, 0, 0, 0, 1. Now the steps are: reduce first is A11 to 1, A12, A13 to the 0. Next is A22 as 1, then A21 and 23 as 0. A33 as 1 and A31 and 32 0. Then you will get again, here is a identity A inverse into identity, that is another matrix C. Therefore A inverse is equals to the required matrix. Now another method to find out the inverse is, that is, to find out the adjoint of a matrix. To find out the adjoint, first find minor, then cofactor, then adjoint it, find the determinant of the matrix, then you will get, use the formula A inverse is equals to 1 upon determinant of A into adjoint of A. जेव्हा प्रश्न येतील त्यावेळा आपण त्या टाईपचे प्रॉब्लेम्स येतील तेव्हा मी एक्सप्लेन करणार हाऊ टू फाइंड आउट द मायनर कोफॅक्टर. ओके, नाउ लेट अस स्टार्ट द एक्सरसाइज 2.2. Exercise 2.2. The first example, find the cofactor of the elements of the following matrices: -1, 2, -3, 4. Now see this here. Here A11 is equals to -1, A12 is equals to 2, A21 is equals to -3, A22 is equals to 4. Now it's a minor, M11 is 4. Then how to find out this 4? If you take this element -1, then go this, reduce this horizontal, see this horizontal, see this in a downward direction. Which is element is present there? 4 is present there. Therefore M11 is 4. म्हणजे आपण समोर बघायचंय, खाली बघणार. आणि कुठला एलिमेंट राहतो तर 4. 4 is the minor of a small a11, that is capital M11 is 4. Now to find out the minor of a12, पुन्हा या 2 कडे येणार आपण. इथे खाली बघणार आणि समोर बघणार. कुठला एलिमेंट राहतो तर -3. Therefore the M12 is -3. See this here. M12 is -3. Again see this. This is A12. See this downward direction, horizontal direction. Which is element present there? -3 is present there. Now the next A21. Now to find out A21, this is the element A21. Again see this upward direction, horizontal direction. Which is present there? 2 is present there. And therefore the minor is 2. For the 4, see this in upward direction, horizontally, you will get -1. And this is the answer. These are the minor element, minors, and now cofactor. Now the cofactor, that is a capital, it is denoted by the capital A Ij, that is A11 is equals to always -1. म्हणजे प्रत्येकदा आपण असं लिहिणार A Ij is equals to -1 raised to I plus j plus Mij. This is the formula. Therefore, the next, the cofactor, that is a -1 raised to 1 plus 1 is +1. And here is a 4. 1 into 4 is 4. M12. Again, -1 raised to 1 plus 2. M12. That is -1 and -3. That will become plus. Next is M21. Sorry, here is A12. Next is A21. That is equals to -1 raised to 2 plus 1. Again, you will get the minus sign there. Into M21. That is a -1 into 2. That is a -2. Next is A22. That is equals to -1 raised to 2 plus 2 M22. And that is equals to, what is that? 1 into -1, that is a -1. Therefore, the cofactor matrix is 4, 3, -2, -1. And this is the answer. Now the next matrix is, the matrix is 1, -1, 2, -2, 3, 5, -2, 0, -1. Now to find out the cofactor of this matrix. Now first the elements. Minor and the cofactor. The first element A11 is 1. Therefore, it's a minor. M11 is equals to. Now see this. How to select this M11. Now see this horizontally and vertically downward direction. Then you will get this element. And this is the minor of A11. Now the next is Again, see this here. The element is 3, 5, 1, 0, minus 1. Simplify it. Minus 3, 0. Therefore, M11 is minus 3. It's a cofactor. A11 is equals to minus 1 raised to 1 plus 1. M11. That is equals to minus 3. Next is A12. The element is minus 1. Therefore, M12 is equals to, see this here. This is the minus 1. Now see this horizontally and vertically downward direction. Then you will get minus 2, 5, minus 2, minus 1. Minus 2, 5 and minus 2, 1. Therefore, its value is plus 2 minus in bracket minus 10. That is M12 is 12. And overall this is a minus. A12 is minus 12. Next is A13. Let's see this again. A13 is 2. M13. M13. Now this is the element 2. See this horizontally and in downward direction. Then which is the element is present? Minus 2, 3 and minus 2, 0. Minus 2, 0. Therefore, its value is 0. Minus in bracket minus 6, which is 6. Therefore, M13 is equals to 6. A13 is equals to minus 1 raised to 1 plus 3. That is M13. That is equals to 6. Next is A21. Now see this element A21. This is the A21. And now see this upward and direction, downward direction. This will go and again this. Then what will be the? It's a minor. Minus 1, 2, 0, minus 1. Minus 1, 2 and 0, minus 1. Now evaluate it. You will get 1, M21. Again A21 is equals to minus 1 raised to 2 plus 1, M21. That is equals to minus 1. Next is A22. A22 is 3. Therefore, M22 is equals to, now see this. That is a 1, 2, minus 2 and minus 1. You can see this also. That is equals to 3. Therefore, A22 is equals to minus 1, 2 plus 2. That is equals to 3. Overall, it is a 3. I will show A22. A22 is 3. A23, that is equals to 5. Therefore, M23 is equals to 1 minus 1 minus 2, 0. And you will get 0 minus 2. That is equals to minus 2. Now see this here. the value of this element, that is a 2 2. The question was here, that is if we delete this element upward and downward direction and delete the horizontal in horizontal direction, forward and the backward of the 3, then you will get 1 2 minus 2 minus 1. This is a A22. That's I want to show you. This was A22. You can see this here, A22 here. Now next is A23. Then delete upward and downward direction and the horizontal direction. Then you will get 1 minus 1 minus 2 0. Now see this here also. 1 minus 1 minus 2 0. That is A22 raised to minus 1 2 plus 3 M23, which is minus 1 into minus 2. That is A23. That is equal to 2. The next element is A31. Now see this here. I will show you. This is the A31. Delete this element and delete. That is a minus 1, 2, 3, 5. M31, that is equals to minus 1, 2, 3, 5. Therefore, it is a minus 5 and minus 6, minus 11. And therefore, A31 is equals to minus 1 raised to 3 plus 1. M31, that is equals to minus 11. Next is A32. Again, I will show you this. A32. How to find out it? A32. This is delete this element in upward direction and down in this horizontal. Then you will get 1, 2, minus 2, 5. म्हणजे सरळ वर बघणार आणि हॉरिझॉन्टली बघणार. काय काय शिल्लक राहतं? 1, 2, minus 2, 5. Here is a 1, 2, minus 2, 5. And it's a determinant. You can solve it. 5 plus 4, that is equals to 9. Therefore, A232 is equals to minus 1 raised to 3 plus 2. M32, that is minus 9. And the A32 is minus 9. The last element is A33. A33, that is equals to minus 1, and its a minor is, see this, how to find out it. Now this is minus 1, A33. Now see this in upward direction and in horizontal. You will get 1. This is the minus 1, minus 2 and 3. One minus 1, minus 2, 3. That is equals to 3 minus 2. Therefore, M33 is 1. Therefore, A33 is equals to minus 1 raised to 3 plus 3 into M33, that is 1. A33, and in this way we get the cofactor matrix. Cofactor matrix of A. Will be step by step all the elements. This is the cofactor matrix. Minus 3, minus 12, 6, -1, 3, 2, -11, -9 and 1. Now see this again here. I will show you how to find out. You can write down from the screen also. This was also the first problem. You can have the screenshot of this first. This is the second one. Now this is big example, minor and cofactors. You can take the screenshot up to this 12. And this. A33, and in this way you will get the cofactor matrix. Now see this. That is the question number 2. Find the matrix of the cofactor for the following matrices. A11 is 1, therefore M11 is -1. I had explained here, delete this and these two. Therefore A11 is equals to -1 raised to 1 plus 1 M11, that is -1. A12 is equals to 3, therefore M12, that is equals to 4. Therefore A12 is equals to -1 raised to 1 plus 2, that is -4. A21, this is, then you will get 4 element there. Therefore A21, that here is 4, A21 is 3, and overall, sorry, it is a -3 by mistake. I will change this. I will show you this one, and this is the, okay, this is the -3. Therefore the cofactor matrix, cofactor matrix A11, A12, A13, A12, that is equals to, substitute the elements, that is -1, -4, -3 and 1. And this is the answer. Now if you want to write down this, you can, yeah, this is the answer. You can take the screenshot of this. Again I am repeating here, this is the A11, 1 is, therefore it is a -1, and overall it is a -1. A12, therefore it is a 4, and overall it is a -4. A21, this is 4, therefore it is a 3, and 21, it is a minus, therefore it is a -3. A22, therefore here is a A22, therefore it is a 1, and overall it is a 1. And one thing is that the signs are here plus, minus, minus and plus, like this. This is a cofactor matrix. Again the next example. Now here we will find out A11, which is 1 here. Therefore now see this horizontally and see this in downward direction. You will get 1, 3, 3, -5. This is it's a minor if we solve it. then you will get, that is a minus 14. In the textbook, this element is different. I think that it is wrong. A, next is, see this here, A12, this is the A12 element, and see this the horizontally, म्हणजे समोरचे delete करणार आणि खालचे पण delete करणार. Overall you will get this minus 2, 3, 0, minus 5, minus 2, 3, 0, minus 5, and overall you will get 10. Therefore A12 is equals to minus 1 raised to 1 plus 2 M12, and which is equals to minus 10. Now the next, A13. Again for A13 the element is 2 here. Therefore see this in downward direction and horizontally. It is a minus 2, 1, 0 and 3. That is minus 6, 0. Overall it is a minus 6. Therefore A13 is equals to minus 1 raised to 1 plus 3. It is a M13. It's a minus and minus will become plus here. Sorry, here is a, it's a not minus, this is the plus 1, and overall it is a minus 1. M13 is a minus 6, but this become plus. Therefore it is a minus 6. A21. Now this is the element A2. Now see this vertically upward and downward, and horizontally you will get 0, 2, 3, minus 5. 0, 2, 3, minus 5, and solve this. This will become 0 and minus 6. Overall it is a minus 6. Therefore A21 is equals to minus 1 raised to 2 plus 1 M21. Oh, it is a minus, and minus minus will become plus. A21 is 6. Next is A22. Now to find out A22, see in vertical upward direction, downward direction, this will go and this will delete the element. Then you will get only the 4 elements, which are that 1, 2, 0, minus 5. 1, 2, 0, minus 5, and it is a minus 0. Overall it is a minus 5. Therefore A22 is minus 1 raised to 2 plus 2 M22, and that is equals to minus 5. Next, A23. Now this is again very interesting. A23 element. This is, see this upward direction and downward direction. These two will be deleted, and in this direction horizontally. Then what are remaining element? This is the 1, 0, 0, 3. 1, A23, sorry. I corrected it, 1, 0, 0, 3, and it is a 3. Therefore A23 minus 1 raised to 2 plus 3 M23, and overall you will get minus 3. Now we will find out the last, that is a A31. A31 is 0. Now to find out A31, this is 0. See in upward direction and downward direction. You will get only these elements. Therefore, zero, 2, 1, 3, solid, you will get minus 2. Therefore, A31 is equals to minus 1 raised to 3 plus 1, that is a minus 2. Now A32, see this here, A32, this is, see in upward direction and horizontally, you will get 1, 2, minus 2 and 3, 1, 2, minus 2 and 3. Therefore, this is the 3, minus 4, minus 4, 7. Therefore, A31 3, 2 is equals to minus 1 raised to 3 plus 2, that is equals to minus 7. A33, that is it's a minus, A33 is minus 5. Therefore, you will get 1, 0, minus 2, 1. This is the therefore you will get 1. Therefore, A33 is equals to, or you will get minus 1 raised to 3 plus 3. And it is 1. All the elements were completed now. Therefore, the cofactor matrix this is the, that is minus 14, minus 14, minus 10, minus 6, 6, minus 5, minus 3, minus 2, minus 7, 1 in this way. Now again you can see from this board, this is the first one. You can have this. I repeated that examples so that you can see the proper determinant of the 2 by 2 order. You can take the screenshot from this. Now we'll see the example number, that is a question number 3. Find the adjoint of the following matrices. Here is A11 is 2, therefore M11 is 5, A11 is minus 1 raised to 1 plus 1, M11 that is equals to 5. A12 that is a minus 3, therefore it is a 3. Therefore A12 is minus 1 raised to 1 plus 2, M12 which is equals to minus 3. A13, A21 which is 3. Therefore M21 that is a minus 3. Therefore A21 is equals to minus 1 raised to 2 plus 1. M21 that is a minus and minus 3, that is a plus 3. A22 that is equals to 5. Therefore M22 is 2. A22 minus 1 raised to 2 plus 2. Therefore that is equals to 2. And therefore the cofactor matrix is that is 5 minus 3, 3, 2. And it's the adjoint of matrices 5 minus 3, 3, 2, and this is the answer. Also you can have the screenshot of this question. This is it. Up to this you can have this screenshot, or you can write down this by pausing to your mobile or tab. Next is this. You will get the adjoint of matrix. Now the second one, 1 minus 1 2, minus 2 3 5, minus 2 0 minus 1. Here A11 is 1. Its a minor is a 3 5 0 minus 1. Overall it is a minus 1. I am writing here directly. Sometimes after having you have the too much practice, then you can find out its minor and its a cofactor. and solve this example by using the direct method also. If you have the command on this type of the matrix, then you can write directly. A13 is 2, therefore M13 is 6, and A13 is equals to 6. This is the first row. Now the second row, A21 is minus 2. A22 A22 is 3. A23 that is equals to 5. Therefore, these two get cancelled. This get 1 minus 1, and overall it is a minus 2 and 2 3. Therefore, it becomes plus. Or to remember this, one thing is that you can remember this like this also. That is, suppose that if you have that is a like this, and if I have this box, I will change the in. And what are the sign that you have to remember? Okay. Now this is the first element, or you will have this is the freehand. Suppose this will be the plus, second minus, again this is the plus. Next element is again minus, here is a plus, and again here is a minus. What about the last? This is a plus 1, that element, and again this is a minus, and it is a plus 1. If you want to find out the direct answer. Now let us A31, it is a minus 2. Therefore, I had written directly. Therefore, you can find out also directly also. A32 is 0. Therefore, M32 is 9. A33, delete this element, you will get 1 minus 1 minus 2, 3. That is a 3 minus 2. That is 1. Therefore, overall it is 1. Now the cofactor matrices. Cofactor matrices minus 3 minus 12 6, minus 3 minus 12 6. Next is minus 1 3 2, minus 11 minus 9 1. This is the cofactor matrix. And what about the adjoint? To make the adjoint, the rows से column करायचे, column से rows करायचे. Now first row will become first column. Therefore adjoint of n. Which is the first row? That is a minus 3 minus 12 6. It will become first column. Second row minus 1 3 2. It will become second column. Minus 11 minus 9 1. It will become third column. Therefore this is the adjoint matrix. can see in a single view also. Now if you want to write down this and see this also here, you can take the screenshot of this. Now we'll see the next example, example number 4. This is the property. It's asked in the board exam, and also it depends. This type of the examples asked in MCQ type questions also. The first is, we find out the determinant of A. To find out the determinant of A, there is a 1, there is a 0, minus 2, 0, 3. Therefore, this will become 0, minus 0. Next is minus. Therefore, here minus and minus plus. Therefore, 3 into 3 is 9. Minus minus will become plus. And last is this 2. This 2 will become 0. And overall, you will get the value of the determinant is 11. Now next, we will find cofactor matrix. Cofactor matrix find out करणार आपण. The first is that is capital A is equals to Aij 3 by 3, where Aij is equals to minus 1 raised to I plus j Mij. Therefore, we find out one by one. Now A11 is a minus 1 raised to 1 plus 1 M11. But what is the first minor? Is 0 minus 2, 0, 3. Therefore, overall it is 0. Therefore, A11 is 0. A12. A12 means that these two will get cancelled. This will cancel. That is a 3 minus 2, 1, 3. 3 minus 2, 1, 3. Solve this. 9 plus 2. That is 11. Overall it is a minus 11. Next is A13. That is, this will get cancelled. This will get cancelled. That is a 3, 0, 1, 0. Minus 1 raised to 1 plus 3 M13. Overall it is a 0. A21, that is a minus 1 raised to 2 plus 1. M21, that is a minus 1 to 0, 3. Solve this, it is a minus 3. Minus minus will become plus, minus in bracket minus 3. Next is A22. Therefore, 1, 2, 1, 3. Solve this. 3 minus 2. Overall it is a 1. Next is A23. A23. Then delete this and you will get 1 minus 1, 1, 0. आपल्याला A23 जर काढायचं असेल तर याच्या खालचे आणि वरचे डिलीट करायचे, समोरचे डिलीट करायचे, म्हणजेच काय मिळेल आपल्याला 1 minus 1, 1, 0. And minus 1 raised to 2 plus 3 is the minus in bracket 1, overall it is a minus 1. A31 minus 1 raised to 3 plus 1. Therefore this, that is minus 1 to 0 minus 2. This is a 2. A32 that is a, these 2 get cancelled, these get 1, 2, 3 minus 2. 1, 2, 3 minus 2. Solve this, you will get minus, in bracket minus 2, minus 6. Overall it is 8. A33 that is a 1 minus 1, 3, 0. And therefore it is a minus 3 minus minus 3, that is a 3. Hence the cofactor matrix is A11, A12, 13, A21, 22, A23, A31, A32, A33. Now write down the 0 minus 11, 0. Next is and last is 8, 2, 8, 3. Now it's adjoint. Therefore first row will become first column, second row, second column, third row, third column. Now we'll verify A into adjoint of A. The matrix is 1 minus 1, 2, 3, 0, minus 2, 1, 0, 3, 0, 3, 2, 0, 3, 2, minus 11, 1, 8, 0, minus 1, 3, multiply it. That is the first row, first column, first row, first column, 1 into 0, 0, minus 1 into minus 11, this is 11, and 2 into 0, that is 0. First row, second column, 1 into 3, 3, minus 1 into minus 1 into 1, minus 1, 2 into minus 1, minus 2. First row, third column, 1 into 2, 2, minus 1 into 8, minus 8, 2 into 3, 6. Now second row, first column, second row, second column, second row, third column, and in this way you can perform the multiplication. And third row, first column, third row, second column, 3, 0, minus 3, and third row, third column, 2, 0, 9. Therefore this is the 11, 0, 0, 0, 11, 0, 0, 0, 11. Now next is adjoint of A into A. Adjoint of A into A, 0, 3, 2, minus 11, 1, 8, 0, minus 1, 3, into A. Now the adjoint of A into A, that is again the first row, first column, first row, second column, first row, third column. Then you will get 0, 9, 2. Next is 0, 0, and 0. And the last is again 0, minus 6 plus 6. Now here is the second row again, first column, that is a minus 11, 3 and 8. Next is 11, 0 and 0. And the last is minus 22, minus 2, 24, 0 minus 3, 3, 0, 0, 0, 0 minus 2, that is a plus 2 and 9. Overall it is 11. And therefore 11, 0, 0, 0, 11, 0, 0, 0, 11. Therefore this is the adjoint of A into A. Therefore last value, that is the determinant of A into identity matrix, which is 3 by 3, that is 1, 0, 0, 0, 1, 0, 0, 0, 1. And that is equals to 11, 0, 0, 0, 11, 0, 0, 0, 11. And hence it is verified. Now the next is, you can see this also here. If you want to write down from the board, you can write down. First find out the value of the determinant. This is the value of the determinant. You can take the screenshot of this. Next is the cofactors. Up to this 822. You can take the, you can write down or the screenshot of this. Next is up to the A22 to A33. Therefore this is the cofactor matrix. Now they are multiplied. A into adjoint of A. 11, 0, 0, 0, 11, 0, 0, 0, 11. Afterwards, adjoint of A into A. Again, you are getting 11, 0, 0, 0, 11, 0, 0, 0, 11. And the last is the final answer, determinant of A into I. And in this way, this is verified. Now the next is find out the inverse by adjoint method. Determinant of A is minus 1, 5, minus 3, 2. That is minus 2 plus 15. That is equals to 13. Which is not equals to 0. Therefore, A inverse exists. First, we find cofactor matrix. Aij is equals to 2 by 2, where Aij is equals to minus 1 raised to I plus j, mij. Therefore, minus 1, 5, this is the, therefore it's a A11 is, this is a 2. Minus 1 is to 1 plus 1 and M11 is 2. Therefore, next is A12. Minus 1 is to 1 plus 2. It is a minus and again minus 3 minus 3, that is a plus 3. A21, this is the minus 1 is to 2 plus 1, that is a 5. Minus in bracket 5. Overall it is a minus 5. Next is A22, therefore you will get, here is a minus 1. M22 is minus 1, therefore overall it is a minus 1. Hence, cofactor matrix is equals to A11, A12, A21, A22. That is a 2, 3, minus 5, minus 1. Now it's adjoint. That is first row becomes first column. That is and second row becomes second column. Therefore, A inverse is equals to 1 upon determinant of A into adjoint of A. Therefore, 1 upon 13, that is 2 minus 5, 3 minus 1. This is answer. Also, you can write down from this here. Find the inverse by using the adjoint method. You can take the screenshot of this. Next is up to this. And again, this is the final answer. That is it. Next is 2 minus 2, 4, 3. This is the therefore it's 6 plus 8, that is 14 is not equals to 0. A inverse exists. That is, determinant must be non-singular. Its value is not equals to 0. Singular means what? The value of the determinant equals to 0. A inverse exists. First we find the cofactor matrix. Aij 2 by 2, where Aij is equals to minus 1 raised to I plus j the first is 2. This is here element 2. A11 minus 1 raised to 1 plus 1, that is 3. A12, that will be the 4, that is minus 4. Next is A21, that is a minus 1 raised to 1 plus 2, minus in bracket minus 2. A22 minus 1 raised to 2 plus 2, m22, that is 2. Therefore, overall it is a 2. Now next is hence cofactor matrix is A11, A12, A21, A22. It's a 3, 2, 3 minus 4, 2, 2. Now it's adjoint. Adjoint of A is equals to 3 minus 4, 2 and 2. Therefore, now A inverse is equals to 1 upon determinant of A into adjoint of A. Therefore, 1 upon 14, 3, 2 minus 1 minus 4, 2. Now see this again here. Same example. You can write down this or take the screenshot of this. Next is up to this. And this is the final answer. Now, next, that is the third one, that is 1, 0, 0, 3, 3, 0, 5, 2, minus 1. Now, find out the value of the determinant. One minus 3, minus 0. Next is 0, 0. Overall, it is a minus 3, which is not equal to 0. Therefore, A inverse exists. Now we have to find the cofactor matrix. Aij is equals to Aij 3 by 3, where Aij is equals to minus 1 raised to I plus j mij. Now here we will find out that is the cofactor minus A11 minus 1 raised to 1 plus 1 m11. There is a 3 0 2 minus 1, 3 0 2 minus 1. Overall it is a minus 2. Next is a 1 2. Therefore this it cancels this. That is a 3 0 5 minus 1, 3 0 5 minus 1. And it's a value is a minus 3, and minus minus will become plus 3. Next is this is the 0, that is a 3 3 5 2. A13 minus 1 raised to 1 plus 3, 3 3 5 2. That is 6 minus 15, which is minus 9. Next is A21. This is again here A21. Therefore, it is a 0, 0, 2, minus 1. That is minus 1 raised to 2 plus 1. A21. That delete this and delete this. You will get 0, 0, 2, minus 1. 0, 0, 2, minus 1. If you evaluate it, you will get 0. A21, A22. Then you will get, delete this and delete this. You will get 1, 0, 5, minus 1. A22. This is 0 and 0. That is 1, 0, 5, minus 1. Which is equals to minus 1. A23. Therefore, you will get 1, 0, 5, 2. It's a minus. Minus 1 is to 2 plus 3. It is a minus. And overall, if you simplify, you will get minus 2. That is A31, 0, 0, 3, 0. A32. Therefore, 1, 0, 3, 0. Therefore, you will get 0. A33. Minus 1 raised to 3 plus 3. Therefore, it's a 3. Therefore, the cofactor matrix A11, A12, A13, A21, A22, A23, A31, A32, A33. Therefore, minus 3, 3, minus 9. Zero, minus 1, minus 2, 0, 0, 3. Therefore, the adjoint of A is equals to 3, 3, minus 9, 0, minus 1, minus 2, 0, 0, 3. I am reading according to the column. Therefore, A inverse is equals to 1 upon determinant of A into adjoint of A. 1 upon minus 3. Next is 3. Minus 3, minus 1. Or you may write like this also. Take the minus n outside. If we operate the minus sign, then you will get, that is, there are the two answers. Sometimes in the textbook this is given, or it is given only the minus 1 upon 3. Two types of the answers are there. Or this I had written. Now again you can write down the answer from this. See this answer. You can take the screenshot of this also. Next is this is the adjoint of A. Therefore, A inverse is equals to 1 upon determinant of A into adjoint of A. That is, A inverse is equals to 1 by 3. Now the next. One two three 024 005. Now first we find out it's a determinant. This is the matrix. Therefore determinant of A is equals to 1 2 3 0 2 4 0 0 5. That is 1. 10 minus 4 minus 2. This becomes 0. 3. Again it becomes 0. Overall it is a 10. Determinant of A 10 is not equals to 0. A inverse exists. First we have to find cofactor matrix. That is a Aij 3 by 3, where Aij is equals to minus 1 is to I plus A Mij. Find out the cofactor A11, that is a minus 1 raised to 1 plus 1, and the matrix is 2405. 2405, then you will get 10. Next is A12, minus 1 raised to 1 plus 2, A12, therefore minus. Therefore you will get 0405, it's a 0. A13, that is minus 1 raised to 1 plus 3, A13, that is a 0200, 0200, that is equals to 0. Next is A21, therefore you will get 2305, that is equals to minus 10 minus 0, that is a minus 10. A22, minus 1 raised to 2 plus 2, 1305, 1305. Therefore you will get 5. A22 is 5. Next is A23. Now this is deleted. This is 1200. This is the 0. Next is A31, that is a 2324. These are the elements. Then minus 1 raised to 3 plus 1, 2, 3, 2, 4. Then you will get 8 minus 6, which is 2. A32. Therefore you will get 1304. 1304. that is equals to minus 4, that is equals to minus 4. And last is A33. If you delete this, these two, that is 1, 2, 0, 2. 3 plus 3, 1, 2, 0, 2. Therefore, you will get 2. These are the cofactors. Now we'll write the cofactor matrix. Ten, 0, 0, minus 10, 5, 0, 2, minus 4, 2. Now it's adjoint. Adjoint of A is equals to 10 minus 10, 2. Next is 0, 5 minus 4, 0, 0, 2. A inverse is equals to 1 upon determinant of A into adjoint of A. 1 upon 10, 10, 0, 0, minus 10, 5, 0, 2, minus 4, 2. And this is the A inverse. Now, next is again, see from the board, and take the screenshot of this. The value of the determinant is not equals to 0. This is the first part. Next is the values of A11, A12, A13. And next is A21, A22, 23. And A31, A32, A33. These are the values. Afterward, you would get the cofactor matrix. Therefore, A inverse is equals to determinant of A into adjoint of A is equals to 1 upon 10. 10 minus 10, 2, 0, 5 minus 4, 0, 0, 2. Now the next is find the inverse of the following matrix. Find the inverse of the following matrix A, that is the 1, 2, 2, minus 1. Let A is equals to, therefore determinant of A, that is equals to minus 1, minus 4, minus 5, which is not equals to 0. Therefore, A inverse exists. Consider A into A inverse is equals to I. That is, here we are applying the row transformation. 1, 2, 2, minus 1, A inverse is equals to 1, 0, 0, 1. Now our objective is that first make this element as 1. Yes, it is already 1. Now make this 2 as a 0. That is why R2 minus 2 times R1 we get. Perform the same operations on the right hand side also. That is a 1, 2, 0, minus 5, A inverse. This is 1, 0, therefore minus 2, 1. Next operation, make this minus 5 as 1. Therefore, by minus 1 by 5 R2, we get, that is 1, 2, 0, 1, A inverse is equals to 1, 0, minus, that is 1, 2 by 5 and minus 1 by 5. Next is make this 2 as a 0. That is a R1 minus 2 times R2. Therefore, you will get 1, 0, 0, 1, A inverse is equals to, that is a 1 minus 2 times, that is 1 minus 4 by 5, which is 1 by 5. This is the 2 by 5 and as it is. This is identity matrix. Identity into A inverse, that is A inverse. Therefore, A inverse is equals to 1 by 5, 1, 2, 2 minus 1. See this again here. Find the inverse of the following matrices: A1, 2, 2 minus 1, A inverse exists. Next is A into A inverse is equals to I1, 2, 2 minus 1, R2 minus 2 times R1. Next is by minus 1 by 5 R2 we get. Next is make this element as 0, 2. Therefore, R1 minus 2 times R2 and this is the inverse. Second, 2 minus 3 minus 1, 2. Determinant of A, 2 minus 3 minus 1, 2. That is a 4 minus 3, that is 1. A inverse exists. Consider A into A inverse is equals to I. That is a 2 minus 3 minus 1, 2, A inverse, 1, 0, 0, 1. Now make R1 plus R2, then this 2 will become 0. आपल्याला इथे 1 आणायचं आहे, मग काय करावं लागेल की या -1 वर 2 मध्ये ऍड केला तर you will get 1. And again this, that is a -1, -3 plus 2, that is a -1 here. This is -1, -1, 2, and on this side 1, 1, 0, 1. Now next is make this -1 as a 0, that is a R2 plus R1. Therefore 1 minus 1, 0, 1, A inverse, that is here is a 1, 1, here is a 1, 2. Next is R1 plus R2 by R1 plus R2. Therefore you will get 1, 0, 0, 1. A inverse is equals to 2, 3, 1, 2. Therefore A inverse is equals to 2, 3, 1, 2. Now see this again here. Determinant is not equals to 0. Next A inverse exists. Apply R1 plus R2, then you will get A11 as 1. Next R2 plus R1, then you will get A21 as 0. By R1 plus R2, then you will get A12 as 0, and hence we get the identity. Now the next is Next example. 0, 1, 2, 1, 2, 3, 3, 1, 1. By R12, determinant of A 0, 1, 2, 1, 3, 1, 2, 3, 3, 1, 1, which is not equal, which is equals to 0 into 2 minus 3 minus 1, 1 minus 9 plus 2 in bracket 1 minus 6, 0 plus 8, that is minus 10 equals to minus 2, which is not equals to 0. Therefore, A inverse exists. A into A inverse is equals to I. Now this is the 3 by 3 matrix. We'll require 6 operation, minimum 6. Minimum, that is a minimum, not maximum 6 operations. Now here is at A11 is 0 and here is 1. Therefore, we'll R12 operation. At R12 we get 1, 2, 3, 0, 1, 2, 3, 1, 1. A inverse is equals to 0, 1, 0, 1, 0, 0, 0, 0, 1. Therefore, next is make this 3 as 0. R3 minus 3 times R1. Therefore, you will get, we get 1, 2, 3, 0, 1, 2, and this will become 0. And here is 1 minus 6 means minus 5 minus A inverse and the same operations. ज्या रोज इंटरचेंज होत नाही त्या आधीच आपण लिहिलं तर चालते की आपलं निम्म काम आधीच होत असते यामध्ये. नेक्स्ट इज now this is already 1. Now make this 2 and minus 5 as 0. Therefore we will R1 minus 2 times R2 and R3 plus 5 times R2. We get 1, 0, minus 1, 0, 1, 2, 0, 0, 2, A inverse. Minus 2, 1, 0, 1, 0, 0, 5 minus 3, 1. By 1 upon 2 R3, that is, we will make this 2 as 1. Therefore, these are the rows, they are not interchanging, remains constant. 0, 0, 1, A inverse. Again, there is a minus 2, 1, 0, 1, 0, 0, 5 by 2, minus 3 by 2, 1 upon 2. Therefore, by R1 plus R2, R3, then you will get, and R2 minus 2 times R1. We get this is the identity matrix now. That is 1, 0. R1 plus R. This was my last step. Therefore, you can take that is a 2 as a common. Then you will get A inverse is equals to 1 minus 1, 1, minus 8, 6, minus 2, 5, minus 3, 1. Now see this again. If you want to write down from the board, you can take the screenshot of this also, or you can write. This is the determinant, which is minus 2. A inverse exists. Next step, A into A inverse, R12. Now my next step, therefore A inverse. Take 1 upon 2 as a common. Therefore A inverse is equals to 1 upon 2, 1 minus 1, 1 minus 8, 6 minus 2, 5 minus 3, 1. Now the last example, that is a 2, 0 minus 1, 5, 1, 0 and 0, 1, 2. Here is a, see this again, we have this. Next is the matrix 2, 0 minus 1, 5, 1, 0, 0, 1, 3, determinant of A, 6, 0 minus 5, that is 1 which is not equals to 0. Therefore A inverse exists. Consider A into A inverse is equals to I. Therefore 2, 0 minus 1, 5, 1, 0, 0, 1, 3, A inverse 1, 0, 0, 0, 1, 0, 0, 0, 1. That is 3 times R1 we get 6, 0 minus 3, 5, 0, 1. These two second and third row remain unchanged. In this way here is also 3, 0, 0, 0, 1, 0, 0, 0, 1. Now next is by R1 minus R2. Therefore you will get 1 minus 1 minus 3, 5, 1, 0, 0, 1, 3, A inverse 3 minus 1, 0, 0, 1, 0, 0, 0, 1. Next is R2 minus 5 times R1. We get that is 1 minus 1 minus 3, 0, 6, 15, 0, 1, 3, A inverse. R2 minus 5 times R1. This is R2 minus 5 times R1. The same way here, minus 15, 6, 0, and last is unchanged. That is 0, 0 is 0, 0, 1. Next is make this 6 as 1. That is R2 minus 5 times R3. Therefore this is 1. So we can perform the same operation at that time, that is a R1 plus R3 is also possible. R1 plus R2 and R3 minus R2. A inverse minus 15, 6 minus 5, which is not changing. This is R1 minus 12, 5 minus 5, 15 minus 6, 6, and make this 3 as 1 now, by 1 by 3, R3, therefore 1, 0, minus 3, 0, this is 1, A inverse, that is a minus 12, 5, minus 5, minus 15, 6, and here is a 1 by 3, 5, minus 2, and 2. Last operation is R1 plus 3 times R3, we get the identity matrix. A inverse, and that is equals to these are not changing. The row which is changing now, this finally शेवटी लिहिणार आपण ती ज्यामध्ये बदल होणार ते. Therefore A inverse is equals to 3 minus 1 1 minus 15 6 minus 5 5 minus 2 2. This is the inverse, and in this way we have completed the topics. Find out the inverse of a matrix by using rows or column transformation and by adjoint method. Now we'll see in the next video. Till then, goodbye.